All right, so before we get to the notes, I want to talk about a couple of things. So we talked about derivatives, right? We got to be able to find it the long way, the limit way. And these are the different ways you can show that you took the derivative. If you have f of x, then you have f prime of x. You can have y prime, dy dx, or d dx of f of x. But I put in red X on this one because although it is acceptable and you may see it, that's not really what we use in AP. You probably wouldn't see it like that on a test. Not to mean that you would never see it like that. So we're just going to make sure that if we wanted, like if we have y instead of f of x, we're going to use this instead of this. Okay? Does that make sense? So we'll look at those different ones. All right. So then the next thing is this. And some of you already kind of know the answer to this, but let's let the people that may not know see if they can come up with it. So I have 4 functions. 3 of them, I have their derivatives up here. Okay? And so we're going to talk about a couple of different shortcuts today so we don't have to go through the limit process every time. And the first one's a power rule. So if we have a polynomial, so if I have f of x equals x, the derivative is 1. X squared is 2x. X cubed is 3x squared. Okay, so do you notice a pattern there? Or maybe if I said, all right, so then give me, if I had f of x equals x to the nth power, what would f prime of x then look like? So we can generalize it. N, x, n minus 1. Oh, we haven't done this yet. Well, we haven't done it yet, so it's fine. But do you see it like, so this is a 1 here that we don't normally put, but it's there, right? So 1 times x is just 1, and then that would make that x to the 0 power, which is 1. So this becomes 2x to the first, 3x to the second. Make sense? So that's in general what our power rule is. So let's think about this one then. F of x equals x squared. I want to change that, so I'm still at f of x, into fractional exponents. What would x, the square root of x, what is that? X to the what? X to the 1/2. So I have x to the 1/2 power. Right? So now I want to find the derivative using this rule. F prime of x is equal to, so I do multiply by 1/2, right? Times x to the, what's 1/2 minus 1? Negative 1/2. And what do negative exponents do to variables? What do you mean by it? Goes into the denominator, right? So when I rewrite this, because we don't want to leave negative exponents, we use them, but we don't want to leave them. In the numerator, I would just have 1, and in the denominator, I have a 2, and then an x to the 1/2, where I could write it as x, the square root of x, but I can also leave it like that. Okay? Make sense? Do we understand why the 2 went underneath also? Because it's like having 1/2 times 1 over x to the 1/2. So when you multiply straight across, that's what you get. Okay? So this, in a nutshell, is your power rule. Okay? So let's look at our basic differentiation rules. Before we actually do that, so far we've been using the limit definition to find derivatives. Now we will be learning to several differentiation rules to allow us to find derivatives without the direct use. Like we still need to know how to do it, but we don't have to have the direct use of that. So let's go back again. Oh, well, it helps if I spell it right. Derivative. Okay. There you go. Left out a bunch of letters. I don't know what I was spelling. What does the derivative give us? The slope. Okay, so it is the slope of what? Of a tangent line at a point, right? So that's what it gives us graphically. What kind of rate of change is that slope? Instantaneous. Very good. It's a big $5 word, right? Instantaneous rate of change. Because we still have to keep in mind why we're even doing it. If we see derivative, we need to think slope of the tangent line. Or if it says slope of the tangent line, I need to think derivative, like either way. Okay, so it says if n is a rational number, then the function f of x equals x to the n is differentiable Okay, so if I can take the derivative, it's differentiable, bless you. And so if I take the derivative of x to the n, I'm going to get n times x to the n minus 1 power, like we just looked at. Okay. So we're going to use the power rule to find these derivatives. We do not leave negative exponents or complex fractions. So complex fractions is your fraction of a fraction. So this is f of x. I can now do f prime of x. Got to make sure we label them correctly. Is this a pretty simple one to do the power rule with? 7x to the 6th. Very good. Now for b, I think I want to rewrite g of x. So this is just g of x, not g prime of x. I need to rewrite it with fractional exponents. So this will give me x to the what? 1/3 power. Then I can do g prime of x. That'll be 1/3 times x to the what? Close. Negative 2/3, because I got to do 1/3 minus 1, right? So that's going to be a negative 2/3 power. So that means that g prime of x then, because I can't have a negative exponent, that's equal to, I'll have a 1 in the numerator, 3x to the 2/3 in the denominator. And make sure your 2/3 looks like an exponent, doesn't look like you're multiplying it by it. That's not the best, but I want to stand in the way to fix it. We all good? What questions you got? All right. So I have y equals, so I'm going to rewrite y equals, and I want to get that variable out of the denominator, so I can write this as x to the what? Negative 2 power. Okay. So now I have y and not f of x, so I'm not going to do y prime. Remember, instead we're going to say it's dy dx. It's the derivative of y with respect to x. So that's equal to, I'm going to take that negative 2, multiply it out here, so negative 2x to the what? Negative 3, because you have to subtract 1, so pay attention to your exponents. Okay, so that means that dy dx is equal to, and I'm of a fraction, my denominator is x cubed. Does the 2 go on the top or the bottom? Top, negative 2. Or the negative could go out front, it doesn't matter. Everybody good? What questions you got? Okay. All right, so let's rewrite f of x. This would be x to what power? 4/3, because your cube root is 1/3. This is a 4, so it's x to the 4/3. You do f prime of x. Is that it? All good? These are my answers here. Oh yeah, that's absolutely fine. Yes. If you did f prime of x, it could be, and then put 4x to the 1/3 over 3. They're really the same. And kind of, if you're just going to stop there, you know, either one of them is totally fine. And depending on what you're going to do with it next, one might be better than the other. And so maybe you would have wanted to leave it like this, but I mean, obviously you don't know that at this point. That's a good question. Anything else? Okay, don't be afraid to ask me a question. All right, find the slope of the graph of f of x equals x to the 4th when blank. All right, when I want to find the slope of the graph, means I need the slope at a point. So what do I have to find? Okay, if you want to find the slope of a graph at a point, you want the slope of the tangent line, what do I have to find? The derivative. When you see slope of the graph, just like when you would see rate of change, you need to think, oh, that's slope. When you see slope, you need to think derivative, f prime. Okay? So we have f of x. It's x to the fourth. So f prime of x is going to be what? 4x to the third. Very good. So the slope of the function, the slope of the graph at x equals 1 is f prime of negative 1. Right? So when I substitute that in, I get 4 negative 1 cubed. So what's negative 1 cubed? Negative 1. F prime of negative 1 is negative 4. So that is the slope of the graph when x equals negative 1. So same function, x to the fourth. Let's think about what x to the fourth looks like. X to the fourth is just, looks like a parabola, right? Okay. So when x equals 0, I need f prime of 0. That's equal to 4 times 0 cubed. So f prime of 0 equals 0. And that should make sense because you're looking for the slope of the line that's tangent to the function at 0. It's going to be right there. That has a slope of 0, right? At negative 1, I should have a negative slope. When x is 2, and my point's like right here, I can see I should have a positive slope, right? Kind of look at it on the graph. And so f prime of 2 is equal to 4 times 2 cubed. So f prime of 2 is equal to 32. Kind of putting all this stuff together, all right? Got to make sure you know what you're being asked to do. Just because you can do it all doesn't mean you know what you're being asked to do. Okay. This one says find the equation of the tangent line of this graph when x equals negative 2. All right, if I need the equation of the tangent line or the equation of any line, I need a point and I need a slope, right? So my point is going to be at negative 2 f of negative 2, right? That's how I find it. My slope is going to be f prime of negative 2 because it's the derivative. Does that make sense? All right, so we can do this real quick. It's negative f of negative 2 is going to be what? F of negative 2 is just 4, right? So my point is going to be negative 2, 4. Got my point. Then I am going to need f prime of x. That's going to be 2x. Right, there we go. So then I go find the slope. I'm using f prime for the slope. And so this is going to be 2 times negative 2. So it's negative 4. All right. Everybody with me? Anytime you have to write the equation, write point and slope and make sure you find the actual point you need using f of x. So point is always using f of x. Slope is always using f prime of x. Every time. So now to write the equation of the line, I'm using this point and this slope. So I get y minus what? Minus 4 equals negative 4 times x what? Plus 2. We're good? And you can leave it like that. If you need to do something else with it, maybe you need to move the 4, maybe you have to match something on a multiple choice, but this is your answer right here. Okay. We good? Okay. Writing equations of lines and finding slope. It's like back to algebra 1, right? All right, so let's talk about some other special derivatives here. What if c is a constant, if it's just a number? Okay? Like let's say we had f of x equals 5, and I got to take the derivative. So let's think about this as using our power rule. I don't have a variable here But if I wanted to say I have an x here and I still need it to be equal to 5, I need this to be 1. How do I make this have a value of 1? What would my exponent have to be? 0, right? So 5 and 5x to the 0 power are equal, right? Because x to the 0 power is just 1. You with me on that? So if I want to take the derivative, and I just use my power rule, I take this 0, multiply it by 5, what do I get? 0. 0 times 5 is 0, it's okay. 0 times 5 is 0, and then I would get 0 times x to the negative 1, but what does that give you? 0, right? It doesn't really matter what x is. So the derivative of a constant is just 0. It's that easy, but that's why. We use the power rule for it. Then we have the constant multiple here. So if I have f of x equals 3x squared, that's what it means by this right here. Basically, you factor this out in front of it, you take the derivative and then you multiply it by 3. So all that's really happening here is that you have c times n times x to the n minus 1. And then sums and differences. All this is f prime of x plus g prime of x. So it allows you to do more than one term at a time. And then this will be just f prime of x minus g prime of x. So remember, we have to have rules, even if some of them might seem obvious. There still has to be a rule that allows you to do it. Okay. All right, so let's find some more derivatives here. And remember, a derivative is an operation like adding, subtracting, multiplying, and dividing. Okay, you're doing something to it, or I'm taking the square root, I'm taking the derivative. I'm going to rewrite this with a negative exponent. So this would be 2 times x to the negative 1 power. Right? So that means that f prime of x will be equal to, so I'm going to take this negative 1 times the 2, and I get negative 2 times x, and then negative 1 minus 1 is negative 2. So then I get f prime of x is equal to negative 2 over x squared. Everybody okay with that? All right, so we're going to use this rule right here basically for this one. So when I do f prime of t, why am I writing 2? Of t, that's going to be equal to, I'm going to have 4/5, and then I'm going to multiply that by the derivative of t squared. So t squared, I'm going to have 2t to the first, right? Does that make sense? That means that gives me f prime of t equals 8/5 t. You don't always have to write it separately like that. I just wanted you to at least see that. I think I'm going to do that on at least one more of these. But I could have just said 2 times 4/5. It's the same thing, right? You just multiply it by whatever's in front of it. All right, so let's look at this one. How would I rewrite this? Well, yes, when I take the derivative, I am going to have dy dx, yes. But I want to change y first and to have fractional exponents, so that'd be negative 2, what? X to the 1/2. So since I have a number in front of x, I can just take 1/2 times negative 2. What's 1/2 times negative 2? Negative 1. So I get negative x to the what? Negative 1/2, because I have to do 1/2 minus 1, right? And then I can't leave a negative exponent, so my last one would be dy dx equals, and so in the denominator I have x to the 1/2 power, In the numerator, I'd have negative 1. Okay. What questions do you have? All right, you do D. Did you get 2x to the negative 1/3 at some point? Yes? Okay. So then that cleans up to be my denominator. I'm going to have x to the 1/3. The numerator, I have 2. Everybody good with that? Okay, so those are some rationals and irrational numbers, what to do with them, what to do with their exponents. If you have a polynomial, polynomials are nice. These are going to be your favorite to do because they're the easiest. If I have f of x here, I want f prime of x. The rule we're using here are these. Basically saying we get to just take the derivative of each little term. So I start with this one. This one's going to give me 3x squared, right? This one will give me negative 8x. This one will give me 7. What does this one give me? 0. So I don't have to put it, but it gives me 0. You've got to remember that. So there's a constant there. Easy enough? All right, you do F. Got that? 12x squared minus 10x plus 7? Yeah? Okay. All right, so one of the things we haven't learned yet is the quotient rule. So this is a quotient, right? I have variables in the numerator and the denominator. But I don't have to leave it like that, and I don't have to use the quotient rule, which is going to be way more complicated than what we're about to do. And I'm showing you this now because when we get to the quotient rule, some of you are going to try and do something like that with the quotient rule, and the rest of us are going to be done like that. So we don't want to always make things hard. So first we're going to rewrite y. I'm not doing y prime yet, just y. So y equals. I can split this into 3 fractions. I can split this into 5x to the 5th over x. We're going to write out way too much over this first time. Minus 3x to the 4th over x. Plus 4 over x. Do you agree that that's the same thing as what we have up there? Okay, so now, still have y, haven't taken the derivative yet. What's 5x to the 5th divided by x? 5x to the 4th. Minus 3x cubed, right? Plus 4x to the what? Negative 1. Now we can take the derivative just like we have been. So my dy dx is going to be 20x cubed minus 9x squared minus 4x to the negative 2 power. And then I just have to fix this last term. So this will give me dy dx equals 20x cubed minus 9x squared minus 4 over x squared. Okay. We good? Good. All right, y'all do H then. Well, I probably should have started this one for you, or with you rather. I would rewrite g of x before I did anything to make that a negative 1/2 times x to the 4th. You don't necessarily have to rewrite it that way, but you want to treat it that way. Otherwise, it makes things a little weird. Sorry, I thought there was a variable. I wasn't looking at what it was. So we'll just do this one together then. So that's just g of x. So then when I do g prime of x, 4 times negative 1/2 is negative 2x cubed plus 9x squared minus 2. Okay. We good on the power rule? Make sure you understand your negative powers and your fractional powers, or exponents rather. All right, let's grab the next one. So now we got some trig stuff. I'm going to show you why these two work. You're going to take my word for the rest of these, and then I will show you why they work in a few days after we learn something else, okay? Because otherwise it's a little too confusing. So let's just take sine of x. So I'm going to draw a little sine, one cycle of sine over here. So sine looks something like that, right? And let's just do the key points here, our anchor points. So if I take the derivative, remember the derivative is the slope of the line at a point. So let's use 0, 0. The slope of this tangent line, this line would look like that. What does that look like the slope is? It is definitely positive. Does it just look kind of like the parent function? It's 1. So we're here at 1. Then here, what's the slope there? 0. Then what would the slope be here? Negative 1. What would the slope be here? 0. And then what would the slope be here? 1. Oh my gosh, it's cosine. Yes. Okay? So the derivative of sine is cosine. So, what do you think the derivative of cosine is? Sine. Good guess. Let's see. See what happens here. So let's see. So the slope here, what's this slope? Oh, I'm sorry. No, that's wrong. What am I doing? It's 0 because there's a little hump there. It's 0. Okay. What's this slope? Negative 1. This slope is 0. This slope is 1. This slope is 0. So is that sine? It's a negative sign. Isn't it just a reflection in the x-axis? So the derivative of sine is cosine. The derivative of cosine is negative sine. Okay. So, and then I want you to write this up here. We have, let's see. All cofunctions have negative derivatives. Okay? So your cofunctions are cosine, cosecant, cotangent. So even though I haven't told you what cosecant and cotangent are, they're negative. Secant and tangent are positive. Okay? So all of the cofunctions, negative derivatives. Okay? And again, I will show you, we'll look at why these are what they are. But so this one is secant squared. The derivative of tangent is secant squared. The derivative of cosecant is negative cosecant times cotangent. Secant is secant tangent. Secant x tangent x. And then this is negative cosecant. We're all good with that so far? So these, you got to know. And we'll come up with some ways to remember them. But right now, you should at least know these two, and then all cofunctions are negative. We're going to start with that in our brains, and then we'll get the rest, okay? All right, so let's use these. We're going to find the derivatives of the following functions. So I have y here, and I want dy dx. So this first part right here, I'm just going to do just like we've been doing. It's just the power rule. So this is going to give me 12x. Then I'm going to have 5 times whatever the derivative of cosine is, which is negative sine. So this is negative 5 sine x. And that's your answer. Okay. Right now you can use the little chart, but we're going to need to know them. All right, so then f prime of x. So I'm going to have 1/2 times whatever the derivative of sine is. What's that? Cosine. So I'll have 1/2 cosine x. What's the derivative of negative 4? 0. So I'm done. All right, so I think I want to rewrite this one before I do anything else. So I'm going to have f prime. I'm not going to have f prime. I'm just going to have f, which was the point I was getting at. I had to erase so many primes when I was working this out because I kept telling myself, I'm going to redo f, and I'd write f prime every time. So this is going to be 6x to the 1/2 plus 3 tangent x. So now I'm going to do f prime because I'm taking the derivative. That's an operation that you're doing. 1/2 times 6 is 3. So it'd be 3x to the what? Negative 1/2 plus 3 secant squared x. Then do I need to clean it up a little bit? Yes. So this gives me f prime of x equals, I have a fraction. In the denominator, it's x to the 1/2. My numerator is 3 plus 3 secant squared x. Now, this isn't part of this question, but I'm just going to ask you. If we had to go farther with this and do something with it, do I have a GCF here? What could I factor out? A 3. I could factor out, they both have a 3 in them, right? Can't factor out an x or anything, but I could factor out a 3 if maybe I could cancel. Just want you to be able to recognize GCFs and weird looking stuff too. Okay, I'm not saying we have to do that right now, but all right. So this one I don't think I need to rewrite. I'm just going to have f prime of x. All right, what's the derivative of 1/4? 0, so I don't even have to put anything. Is the derivative of cosine positive or negative? Negative, so it's going to be negative times a negative, which means my answer is positive, right? And my answer is just going to be 7 sine x. Okay, we good? What questions you got? Ask me questions. When you don't ask me questions, I feel like, well, I guess they understand it. I'm doing an amazing job. And then you have questions and it's, okay. I know, I'm sorry. Okay. So here's some of what it might look like on the AP exam, right? So let f be the function given by this. What is the instantaneous rate of change? Okay, so when you see that, that means the slope and it's instantaneous. We are looking for f prime, right? The slope or the instantaneous rate of change, I need the derivative. So I'm going to find the derivative. So f prime of x is going to equal 3x squared, right, minus 12x plus 8. What's the derivative of 5? 0, so I leave it. Okay. So I don't take 3 and substitute it into f of x because I don't need the y value for that point. I need the slope. This is the equation for the slope at this point. So f prime of 3 is going to give me 3 times 3 squared minus 12 times 3 plus 8. So let's see, that's 9 times 3, that's 27 minus 36 plus 8. Is that negative 1? Yeah. Okay. And my guess is that would be on a non-calculator section, which means you can't graph it and try and figure it out from the graph. But all right, well, there is. Part of it's, and it's not half and half, but there's a calculator part and a non-calculator part. Okay, so f prime of 2. Is it asking us to do pretty much the same thing that last one did? Yes, it just didn't use the fancy words of instantaneous rate of change. It's telling us what to do. So if I need f prime of 2, that means I need f prime. F prime of x is going to give me negative 8x to the what? Negative 3 power plus 2 times 1/4 is 1/2 x. What's the derivative of negative 6? 0. So this is the same thing as, and I would highly suggest you rewrite it without negative exponents when you're solving stuff, negative 8 over x cubed plus 1/2 x. And we want f prime of 2, so f prime of 2 is equal to negative 8 over 2 cubed plus 1/2 times 2. So what's 2 cubed? 8. So I have negative 8 over 8, which is what? Negative 1. Plus, what's 1/2 times 2? 1. Negative 1 plus 1 is 0. And a lot of what we do, we'll get super simple numbers. There's no reason to make these crazy big numbers, but you're only going to get the correct numbers if you do the derivative correctly and substitute things in correctly. We good so far? Yes? All right. I think we're going to do one more together, and then I'm going to let you have your stuff to work. All right. Which of the following is, okay, so we need the equation of a line tangent to the graph. So that means I need a point, and I need a slope. The point comes from f, slope comes from f prime. Okay. My x value is pi halves. My y value is going to be the cosine of pi halves. What's the cosine of pi halves? 0. I have y. Well, I put f and f prime. That's fine. So I need dy dx. What's the derivative of cosine? Negative sine. So that means my slope, dy dx, is negative sine of x. So I need f prime of, oh no, here's how we write this. Okay. So since I was using f again, I can't get away from f. Since it's not f and f prime, it's dy dx. The way you show what you're substituting it in, you know how we do like f prime of whatever? This is going to be dy dx evaluated at x equals pi halves. That's what that looks like. Equals, and that'll be equal to negative sine of pi halves. So what's sine of pi halves? 1. And so negative sine of pi halves is negative 1, right? So this is equal to negative 1. So here's my point, here's my slope. So it'll be y minus 0, so I don't even have to put it, but I already wrote minus, so I'm going to, equals negative 1 times x minus pi halves. So then I need to look over here. Well, none of them have the y minus 0, because that was dumb for me to do anyway, but they don't have this factored out either. So I need to make sure I can match this. I know I'm going to have a negative x, so it's not these two. Is it C or D? C, because you got to distribute that negative 1. Okay. What questions you got? You got this? Okay. We're getting more into rule-based stuff where there's processes for you to follow.